So today we're going to talk a bit about Kotlin and some of the advanced language features. It's my first time in New York. I'm super excited about this, so thank you very much for attending this talk. I'm going to tell you a bit about myself first. So I'm a software engineer. I'm from Germany. I work at Ryder currently. It's a legal tech company. We're highly invested in Kotlin, and I've personally been using it for around 3 years now. And this was in 2016. That was right after the 1.0 version was released. And I'm also pretty enthusiastic about the language. I've been kind of working as a teacher and as a pioneer kind of, and I've been pretty active on Stack Overflow as well. So if you want to get in touch, you can find me on Twitter. But without further ado, let's talk a bit about Kotlin here. So this is all based on the newest version 1.3.50, which was released last week, I guess. And so this talk won't cover the like the features you haven't used already. It's more about the features you use every day and you might want to learn a bit more about. So that's basically the idea. Since we only have 40 minutes, I can't cover a lot of topics, but I still try to cover as much as possible. So let's dive right in. So I'm going to show you quite a bit of code today. And the first thing we're going to talk about is infix functions. Okay, so this is not working. My keyboard is not working. That's crappy. Sorry. So I think it's weird. So the first thing I want to talk about is infix functions, and you probably already use it quite a lot. So if you initialize a map in Kotlin, you see code like this, where you use this key, this kind of, it looks like a keyword, which is called to. So in this case, we're associating cities to their countries, and the to keyword looks like it looks like a keyword, but actually, if we write it out, we see that this is actually a function. So it's like you have you have something, you call a function on it, and you pass something in it, and then it associates key with the value. That's basically what the map takes from us. So basically a number of pairs. And this is what we see here. So when we write this out, this is just a wrapper for, let's say, a factory method for a pair. And so it creates a pair. So actually, what the to is, it's not a keyword, it's just a function. And since Kotlin adds some syntactic sugar here, it looks like a keyword. It actually isn't. Another example, this here is a custom function. It's called combine with. And what it does is it combines one list with the other list. And what the implementation looks like is pretty simple. So we just have a combined list, which is an empty list. And we put everything from the left and from the right into that list and return it. And if we then call it, it would look something like this. So we have one list, we say combine with, and we pass in the other list. So if we were getting fancy, we could do something like this, right? So this would maybe look, we might want to have that. And the IDE actually suggests to add an infix modifier to the function. So all it does is add the infix here, and the syntax is fine. So that's basically how infix functions work. And yeah, so the comment here says it's a naive implementation, so the better way would be to use built-in functionality. And Kotlin's standard library already comes with a plus operator for combining lists, so you would rather use this one. And we'll see how the plus works in a minute. So this will be the next topic, but let's quickly recap infix. So infix functions basically let us call functions omitting the dot and the parentheses. And there are some rules, so they always have to have a receiver, basically. So they can either be a member function or an extension function. And they must have exactly one parameter. So you can't have an arbitrary amount of parameters. You always have to have one parameter and one receiver. And that's how it works. And there are a few common infix functions like to, as we already saw, and also bitwise operators like shifting operations. And then there are some operations for strings and iterables. But to be honest, there are not many of them, and you should always use infix functions with care. I mean, it provides a fancy way of providing APIs and stuff, but we don't see it very much. But some libraries make use of it. Okay, so now let's see how operators work like. So what we have here is a pretty simple data class. It's basically a wrapper for two integers, a and b. And what we can do, and here's an FYI, so the following, these are all extension functions. They could also go into the numeric holder class directly. But you can always take all types, also the ones from the Java library, and just extend them with operators. So there's another keyword called operator in Kotlin, which you can use to basically provide operators for a given type. And in this case, we're extending the numeric holder with a plus operator. And what it does is it creates a new immutable instance of numeric holder, combining the a's and the b's from both parts. And what it gives you is you can now use the plus operator. And also interesting to notice that this type here, so we're passing in a numeric holder, but this could also be an integer, if it makes sense for your domain object. Then we can also have that with minus, obviously. We can also have an increment, so we can say we want to make a type incrementable, like that would look like this, so we could use the double plus operator. The same for decrement, obviously here. And then this one's pretty interesting, so you all know from Java that you can basically get values from an array, like with these square brackets. And in Kotlin, you've already used this for lists, I guess, and also for maps. And this is why, this is because we have the chance to add an operator get. So if you have a get operator on your type, you can always use these square brackets. It's called index access operator. And in this case, we're returning A for the index 0 and B for the index 1. Otherwise, we're thrown an exception. And this then looks like this. So you can basically get the first and the second part from this holder using the square brackets. Then we have a contains operator, which enables the in keyword. So this is something you use for sets, for example. So you can check whether some element is part of this set. But you can also do that for your custom types, like here. Like we're checking if 5 is part of the numeric holder, if it's either in A or in B. Then this one is pretty cool as well. It's called the invoke operator. And if you define an invoke operator, you can do anything with that type. But the cool thing is on the call side. So what you do is you can either invoke like call the invoke function directly, or you use just the parentheses, like here. And this is actually, it looks like it's a function, but it's just an instance of numeric holder. But since it's invocable, you can invoke it like this. This is also how lambdas are implemented. So if you have a lambda, it's compiled down to an instance of function. And they also come with an invoke operator, and that's why you can call them like this. Last but not least, we have the compare to operator. It lets you compare two instances of a numeric holder in this case. And this enables a number of operators in Kotlin. So you can use the greater sign, greater equals, and also less and less than or equals. And there are more than that, but these are like the most interesting ones. So we have a number of arithmetic stuff, also unary plus and not and stuff like that, and also a range too. So if you have your type, you can define how a range of these types looks like. This is all kind of enabled by conventions. So if we speak about operator overloading in Kotlin, it's all about conventions, because these functions work by convention, and you can't have your own operators. You just have that predefined set of operators, which you can look up in the documentation. Okay, cool. So another very interesting topic and very important topic is function types and lambdas in the language, and also higher order functions. So if I say higher order function, I'm talking about a function that takes in another function. And in this case, we have a calculate function which takes in an integer and an int mapper. An int mapper is just a type alias for a function type of int to int. Right? So if you have a type alias, you can just use it interchangeably with the underlying type, like this. And so the calculate takes in a parameter of int and a function, and this makes calculate a higher order function. And what you can do is you can return, this function just returns the result of passing in the param to the operation. And the thing is, so if you were to call this function like this, you would pass in a lambda, so the second argument, most of the time. And the thing is that this lambda is being compiled down to a function, so it implies a heap allocation. So it's something we don't want. We don't want to have so many objects, because in Kotlin we're using lambdas we're using many lambdas, and we want to have it we want to have the impact on the heap as small as possible. And what you can do is you can inline your function. And inline is pretty much a fancy word for copy-paste. So what the compiler does, if you inline a function, if you call it, the bytecode will be copied to the place where you call it. So if you call it 5 times, the code will appear 5 times in your bytecode. But the cool thing is that lambdas don't have to be compiled to objects anymore, because everything happens in the call side place, and there doesn't have to be an instance of that function anymore. So inline basically reduces the heap allocations and the overhead. There are certain situations, so in this case the function is pretty much the same, but what it does, it has an intermediate variable here, assigning the passed-in operations to a variable, and then we're returning it in a second step, and there's something going on here, we don't know about that. But the thing is, if we try to inline this part here, the compiler says that it's not possible to assign this operation. This is an illegal usage. And the thing is, if you want to assign something in the language on the JVM, you need to have an object. Otherwise, you can't assign it to a variable. And that's why you can't inline this operation here. What IntelliJ and also other IDEs will suggest is that you add the no inline parameter here. So it says add the no inline to this operation. So now it's an inline function, but this particular function is not being inlined. This doesn't make much sense because we don't have any value from the inline, and now the IDE tells us that the expected performance impact is not significant. So this doesn't make much sense, but you might want to use the no inline if you have a number of functions, and some of them can be inlined and others can't. So why do we need the no inline? So as I said, the inline function can be used if you call the function directly, like the inline function directly, or you pass it to some other inline function. Then it's okay. But if you basically assign it, for example, to an intermediate variable, you can't use it the inline keyword like this, and you might have to use the no inline keyword as well. And there's also one thing you need to think about when inlining. If you have a very long function and you inline it, it will appear multiple times in your bytecode wherever it's being called. So it will make your generated bytecode bigger and bigger. So think about reducing the length of your inline functions. So if you have an higher order function, you can also make that an extension function. So this is the same function from before, but now it's defined as an extension on int, which makes you you can now call it on an integer directly. That's also possible. So there's also one thing that is important to note. I won't go too much into detail here, but if you return from a lambda, you most certainly will return from the outer function. So in this case, you won't return from the each here, but from the outer control flow. So this is called a non-local return. You're not returning from the local lambda, but from the non-local outer function. And we can always fix that using labels, which look like this. So in this case, we're telling the compiler return from this each and not from the outer function. You can also give that a custom name. So here we are referring to it with the function name, but you can also give it a custom name, like some loop. And there's another alternative. It's called anonymous functions. They are not being used that much, but what you can do, it's not a lambda, but it's basically a function which has the same syntax as a function, but it doesn't have a name, which makes it anonymous, right? So the simple rule to remember here is that return returns from the closest function declared with a fun keyword. Again, if you have a look at this guy here, this return returns from this fun, and on the other hand, if you return here, it will return from this fun keyword. So that's basically the rule. Okay, so the topic is higher order functions. So we have a number of higher order functions in the library, obviously. Some examples are the synchronize. In Java, synchronize was a keyword. In Kotlin, it's a function, which also takes in a block, which is then synchronized. We have the use function for try with resources as an alternative for that. And last but not least, we have a lot of collection manipulation, filter, map, reduce stuff. Right, and going one step further, this is also related. What we can do So again, we have a function here, which is an extension function on lists, and it's called doStuff. What it takes is another function, which again takes a list, and then what the implementation looks like is it calls the block, the lambda basically with the instance itself, so with the receiver of this function. And if you want to use it, you have a list here, and you can call doStuff, and you pass in the lambda, which basically defines what to do with this instance. And what we do here, we just print some attributes of this class, like the size and some elements. And the thing is, if you see this it here, so this tells us that the list itself is exposed as it in the block in the lambda. And so what we have here is basically a redundant thing of referring to it. And we don't want to have that, so it should be naturally possible to do this, because we are already in the scope of this list, and we just want to say, hey, you should know that I'm going to do stuff with this very list, so let me just not use any additional qualifier here. And Kotlin lets us do this. So what we can do in the syntax for the library function here, we can just make it the receiver of our lambda, basically. So this concept is called function literal with receiver, or more simple, it's lambdas with receiver, sorry. So what it lets us do, it looks like an extension function, and what we can do is we can now call the ops on this. So because it's basically an extension on the receiver, and then we can also go one step further and just leave out, or just omit this qualifier here. And on the call side, this makes now this code compile, and as you can see, the IDE tells us now that the list is exposed as this and not as it anymore. The library already comes with a with function, which basically does exactly this. It brings some object into the scope of the lambda you pass into the with, and then you can do stuff with that. Okay, so high order functions are obviously a vital aspect of the language. So they appear all over the libraries and all over the standard library. So we all need to know how they work. We can use the inline qualifier or inline keyword to reduce the overhead. And yeah, there's one thing we need to think about. Sometimes it's non-local versus local returns. And yeah, last but not least, we saw lambdas with receivers, and this is a concept invented by Kotlin. So this is the only feature of the language that you won't find in another language. And examples are the apply and the with function. All right, so let's move on to domain-specific languages. So you see them from time to time. A domain-specific language, or short DSL, is basically an abstraction for an API, so you can give that to your user, and it basically provides an easy and expressive way of defining some domain object. For example, Gradle, as a build tool, it provides a Kotlin DSL. This is basically the same idea. So what it does is, if we think of some domain object, so in this case it's a conference object, it has a name and a location, and it has a schedule, which is a list of talks. We can add talks to it, and we can also get the list of talks. We have different talk types. We have a conference talk and a keynote talk. And then we have a talk which is basically, it has a topic, it has a speaker, a time, and a type. And yeah, how would we create an object of a conference? So in this case, we're defining the droidCon NYC conference here. We're defining 2 talks, and we're adding these talks to the conference, right? So this is basically how it could look like. You could go ahead and create a builder pattern, implement the builder pattern in Java. Kotlin gives many ways to simplify this code, but we can also go one step further and create a DSL for this. Just theoretically, we could do that. So what we see here, we have a block called conference, and we assign a name and a location, and then we open a new scope talks, which lets us define talks for that conference, right? So as you can see, we have different ways of defining, adding conference talks or adding talks in general. So in this case, we're just using some factory methods, which lets us pass in the parameters, and this just acts as a factory for the talk domain object. And this one looks a bit different. So at this point, we have something that looks like a sentence, basically. So we have a conference talk at some time given by a speaker titled the cloud in this case. And then last but not least, we have the option to use a plus and say we want to add a talk to this conference. And last but not least, as you can see, we have a block of conferences, but we can also just use the functions directly on the talks, which would look like this, and you could have repeated invocations of this part here. So let's have a look at the implementation. So the conference is basically the entry point here. It's an inline function because it takes in a lambda, so it's also a higher order function. And it takes in a lambda with receiver, and the receiver is a conference DSL. We'll see how that looks like in a minute. And what it does, it creates a receiver, which is a conference DSL, and then applies the config. So it applies the config to an object which is internally created. And this DSL will then hold the initialization. Basically, it will be the initialized conference DSL, and we can retrieve the name, the location, and the talks from it, and we use it to basically create the domain object, the conference itself. Let's have a look at the conference DSL. So what the DSL has, it has a private talk list, which is just the list of talks, and then it has a getter for that, so you can retrieve the talks. Then it has a var name and a var location. So providing a var name and a var location is basically sufficient to enable this syntax here. So since we are passing in a block with a receiver of conference DSL, we can just access the name and the location of that conference DSL without further ado. So you can just reset the name and the location like this. So this is pretty straightforward. But the more interesting part is the talks here. So the talks is like a sub DSL. It's a part of the conference DSL, and it comes with a separate implementation here. It's an inner class, and what it has a reference to the outer talk list. And it has an invoke implementation. So the invoke again takes in a lambda with receiver. Now the receiver is the talk config DSL. And it does the same as the conference class basically. So it applies the passed in config to our very own talk config DSL instance, to the instance here we're currently dealing with. And having the invoke operator basically enables this syntax. So we can call the talks, the talks is basically just a property of the DSL. So we can call that talks now with a lambda. And this is enabled by the invoke operator. So we can now come into the scope of the talks and call all the functions available. And since this is a simple property, we can also just call the functions from that class, like the conference talk. This is just a function provided by this DSL. So if you have the talks, you can obviously call the functions of that DSL. So let's have a look at the implementations of these methods. So conference talk and keynote talk are again straightforward. They just take in the parameters, topic, speaker, and time, and they wrap the call to, as you can see, the constructor of a talk. So that's pretty simple. They just create a talk and add it to the talk list. The same for keynote talk. The more interesting part is the conference talk and the keynote talk. So if we once again have a look at the call here, so we have a conference talk and a keynote talk, and they both refer to a property of this DSL. What they give you a new instance of an empty talk initialized with the type of the conference. And this empty talk is a custom class here, and it comes with a single infix function which is called add. If you call this function, it will give you a time talk because you provided a time which gives you an instance of time talk. This again comes with another infix function called by. If you then apply the speaker, it will give you a timed and author talk. And the timed and author talk comes with another single infix function called title. So you give in the title, and this will basically lead to the creation of the talk because now we have gathered all the information we need to create that object, and we'll add it to the talk list. So this is not that simple, so let's have a look again. So we have a variable here of an empty talk. So if you do that, you get an empty talk, which comes with the add infix function. If you call that, this gives you a time talk, which comes with the by function. You call it with a speaker, which gives you this guy here, which is a timed and author talk, which then comes with a title function, and this ultimately will create the talk for you. So this is something that lets you basically create English-like sentences. It basically reads like a sentence. And last but not least, we have this plus operator here. This is just a very simple extension function making use of operators. So this plus is a unary plus, so you can basically prepend a plus to your type. And what it will do is it will add the talk, the receiver of this function, to your talk list. So these are basically some ideas how you can create a DSL. There are multiple ways, and obviously DSLs make use of many Kotlin features, so you can basically use all the features you have in the language. And what DSLs do, they provide basically a way to create a structure or language for your users. Like this could also be your peers, like a DSL to simplify some domain creation. And yeah, they enable code reusability and type safety. This is very important. So for example, we have an HTML DSL, which lets you write type-safe HTML. This is an idea that comes from Groovy, for example. Groovy also has that. And yeah, it's basically the idea to have type-safe DSLs. And yeah, as I said, it lets you combine a number of language features. Cool, so let's move on to another very interesting topic. It's called delegated properties. So if we talk about delegated properties, we basically want to delegate the accessor logic of our class properties to some external delegate. So we can create a delegate once and reuse it in our code in multiple situations. And the Kotlin library comes with a number of predefined delegates, and we want to have a look at them. So this is just a simple class. And the first important thing here is that it has a property called lazy one, and it delegates to something called lazy. So the by is a keyword from the language. Whenever you see the by, it introduces a delegate. So this property lazy one is delegated and handled by something that comes from this lazy function. And lazy by itself is not a keyword. This is a function also from the library, which creates a delegate for you. And what you then pass in, this is your custom code. You pass in the initialization of this property, and this code will be invoked exactly once, and this is when the property is being accessed the first time. And after that, the initialized value will be returned over and over again. So the code will be executed exactly once. You can also use the lazy delegate locally. This is pretty interesting, let's say. So it doesn't have to be a property. You can also have your local function variables be delegated to a lazy, and also to other delegates, obviously. Then we have an observe property here. So this delegates to the delegated observable. So you basically have a property and you delegate it to an observable, and you pass in a lambda which tells the compiler what you want to do every time the property is being changed. So if somebody reassigned this variable, you would enter this code, and this is like a nonsense implementation, just printing out that the value has changed, but you could do something that makes sense, like telling some other services in whatever, telling somebody that this property has changed, like your view, for example. And then we have a verified property, which is similar to the observable. It's called v2able. So if you delegate to v2able, you also have the chance to intercept the process of reassigning this variable. But the thing is, you can now return false or true. But if you return false, this assignment will not take place. So you can basically have a verification of the newly assigned value. And if you return false, the new value will not be assigned, and the old value will be the same as before. And then we can obviously have our own custom delegates. This here is an example of a custom delegate called modifying delegate. We'll see the implementation in a minute. What it does is it takes in an initial value, and then you tell it what to do with the value. So in this case, we are multiplying it with 10. So the initial value of this custom delegate will be 1000. And when a user basically reassigns custom delegated, it will also go through this block here and multiply it with 10. Doesn't make much sense, but just to give you an idea what you can do. And the implementation looks like this. So the library comes with two optional interfaces. So you can either make a read-only or read-write property. But this is optional. You don't have to implement that. The only important thing here is to provide a set value and a get value function. And it has to look like this. So you can see that the syntax is not very straightforward. And the cool thing about implementing is that you can make your IDE generate these methods for you. So the idea is to implement this interface, so you can directly see how the functions should look like. So the set value here, let's begin with the constructor. So the constructor takes in the initial value and the modifier, which is the lambda we saw, and it will initialize the current value with the init value passed into the modifier. So this is basically the property that is returned from the get value. And on the other hand, you have a set value where you reassign the current value, again applying the modifier to the newly passed in value. And then again, the current is returned. So this is, it's just a wrapper for what happens with your property. So you're delegating to this implementation here. Right, so delegated properties, as I said, they let us reuse property accessor logic. So we can basically extract the logic into some class and reuse it in our code in multiple locations. And as I said, the by keyword is always followed by the delegate. So if you see the by keyword, it's about delegation. And the compiler, if you think about what the by keyword does, the compiler will basically create an instance of the delegate and then delegate to this class, literally. And there are some standard delegates. I've shown the lazy and the observable and also the vtuable. And we can also delegate to a map, for example, directly, because it also has a get value and a set value. So whenever your class has get value and set value and has this basically the signature, right, it can be used as a delegate. And as I said, we can define our own delegates. And finally, there are a lot of frameworks and libraries that make use of this. One example is Exposed, which is the JetBrains library to basically generate SQL code, as one example. Okay, so now let's have a look at inline classes. Inline classes were introduced pretty recently with 1.3. And the idea is basically to provide typing to some general types like strings. And let's have a look here. So we have a fun authenticate here, which takes in a user and a password, both of the type string. And you can basically invoke this function in two ways. Like the expected way would be to pass in the name and the password, but you could, like a user could confuse the order and like pass in the password first and then the name. I mean, this is not the best example, but if you think of an example with like 5 or 6 parameters, it could be possible that somebody confuses the order here. And the idea of inline classes is that you provide, you can think of it like a subclass of string, kind of. So you're basically wrapping a string. This is a name wrapper. It's called name. It's an inline class, and we have the same for the password here. Now, if we could change the authenticate function to take in a name and a password, but now they have types, right? So they are not of type string anymore. Now they have explicit types name and password. For the call side, you will now have to create, or you have to wrap your strings in that newly created class name and password respectively. Obviously, you now cannot anymore call it in the wrong order, because the compiler will be able to check the types. Like you can't pass in the password first and then the name. And the important thing is, well, you could do that with regular classes, right? But the idea is that in the compiled bytecode, the classes won't actually be obvious anymore. In the bytecode, you will still be dealing with strings. So the inline classes don't actually allocate memory on the heap. they are. So the idea is to reuse the underlying type string as much as possible. So it's just a bit more tedious for the API user, because now you have to wrap your string into that name or the password, right? But it gives you type safety. And then we have another example here. It's called parse number. It takes in a string and it parses the string to a big decimal. The implementation is not very important. But it could happen that we have a change requirement here. So for example, we now want to preserve the original value, like the pass string. And what we can do is create an inline class. Let's call it parsable number. And it's being initialized with the original string. And then what we do is we create another property here, which is the parse property. And whenever we access this parse property, we will call this getter here, which will do the parsing, the conversion. And now the cool thing is, if you use it on the client side here, it looks like a normal class which gives you two properties, the parse value and the original value. But the important part is that in the bytecode you won't be dealing with classes. These calls, like this function, will be a static function which will look something like this. It's like a static function where you put in a string and get back a big decimal. So this is just synthetic sugar. Now the API gets a bit clearer here, and you still have the advantage of not polluting your heap with too many objects. So it's important to note at this point that inline classes are still experimental. So if you use them right now, it might be that your code will break in future releases. That's basically what the experimental feature of Kotlin implies. And what it does is it's a wrapper for simple types, as we saw, so we can use it to wrap our integers or our strings, whatever. And as I said, we could always use normal classes to get the same features, but they imply heap allocations, which inline classes try to avoid as much as possible. They might look like type aliases, but they are actually not assignment compatible with the underlying type, so this is basically the difference. If you have a string and a password, you can't use them interchangeably in your code. They are like different types, basically. And this only works if you have a single property in the primary constructor. So as we saw, if we have a name class and we have a single string property, that's fine. You can't have multiple parameters. And but what you can have is member properties and member functions. You can always have that for your inline classes, which is pretty cool. So yeah, that's basically all the features I wanted to cover. So just as a wrap up, I know it looks like many Kotlin features look magical, and we don't really understand how they work. And I personally find it pretty helpful to really look up how they work like. And you can always do that in the documents, in the documentations, obviously. And it's also cool to have a look at the bytecode in the IDE. So if you haven't done that, it's really helpful, and it's not. It might sound like difficult, but it's really not. It's understandable. It compiles down to Java code, so it's demonstrated as Java code in the IDE, and it helps understanding what's going on. And there's also this book, Kotlin in Action. If you haven't picked it up yet, I really recommend to do so. It's the best book out there, and it gives you so many insights and stuff you won't find anywhere online, even not on Stack Overflow, because there's so much expert knowledge from Dimitri and Svetlana in this book, and really you got to read it. So thank you very much, droidCon. If you have any question, we have 1 minute left. Otherwise, you can just come to me afterwards and ask me. Thank you.